Okay, so it's just going to be a really quick video on differentiation. Differentiation is used to basically find the rate of change on graphs. It's super easy to do. So if we start with some easy questions, and then I will go on to some harder questions. So the first one, you normally see differentiation where you've got a y equals something and you've got to find dy over dx. That just means you've got to differentiate it to find the rate of change. Because rate of change is something like, the gradient where you've got the change in your y over your change in your x. That's basically what it's asking for. So in this circumstance, dy dx, you're first going to want to multiply. So in here I've only got one variant I'm looking at. So I just want to do my 7 multiplied by my 2, which is 14. So dy dx is going to be 14. And then you take 1 from the power. So in this case, 2 take away 1 is going to be 1. So your x stays there. Obviously, if you had to the power of 0, then you can get rid of your x. But in this case, it's just 14 to the x to the power of 1, which can be written as 14x. So differential of y equals 7x to the power of 2 is just 14x. And you do that for each variable that is attached. So if we look at the second one, so we've got y equals 3x to the power of 3, take away 8x. So again, we'll start with the first one. So we start with this one, we're going to do 3 times the 3. So the big number times the little number. So 3 times 3 is 9. We've still got an x, and I take 1 from the power. So instead of 3, I've got 2. Now I look at my second variable. So I've got minus 8x. So I do my 8. There's an invisible 1 here. So 8 times 1 would just give me 8. And I take 1 from my x, from my power, and that will give me to the power of 0. So my 9x squared stays the same, and my 8x to the power of 0, so anything to the power of 0 is just 1, so all of this is technically just 1. So it's 8 times 1, which is just 8. So your x basically disappears. So this is 9x squared minus 8. So super easy. Times the big number by the little, take 1 from the power, and that's pretty much it. So in this case, we do 8 times our 3, so 8 3s are 24. Still got an x, and we take 1 from the 3, which is 2. I'm going to look at my next one. So I'm going to do this an invisible 1 and an invisible 1. So 1 times 1 is just 1. Take 1 from the power to make 0. So don't forget, this ends up being nothing. Well, being a 1 really. Now with this next variable, you basically can get rid of it. So any number that's just by itself, you can get rid of it, because there's an invisible x to the power of 0 here, isn't there? And 4 times 0 is just 0, so there would be plus nothing. So your answer to this one would just be 24x squared plus 1, because don't forget, x to the power of 0 makes 1. Let's look a little bit harder. So in this circumstance, so you've got an invisible 1, so 1 times 7 is 7. Got my x, take 1 from the 7 to make 6. I'm going to subtract 3 times 6 is 18 to the power. I'm going to take 1 from my power to make 5. So the 7 comes from doing 1 times 7, the 6 comes from taking 1 from the 7, the 18 comes from 3 times 6, and the 5 comes from taking 1 from the 6. Sometimes when you're differentiating, you've got to find dy2 over dx2, or I can't remember which way it's written, I always write it wrong. And which basically means you've just got to differentiate again. So if I had to find the second derivative, I would just times them again. So I would do 7, lots of 6s, etc, etc. I don't think these questions ask me to do that. So let's try and pick a harder one. I want to see if we've got any negatives. There's a nice fraction one. Let's pick... Ooh, let's do this one. So this is quite a hard one. So we've got y equals 3 over x to the 2. So when we've got a fraction, this is the same as writing y equals 3x to the minus 2. Okay, so those two are equivalent. So I'm going to just rewrite it like that. And then I'm going to differentiate. So I'm going to find dy over dx. Still going to do my 3 times my minus 2, which is minus 6. Got my x, and if I take 1 from the power, I get minus 3. You could technically leave it like that, but I'm going to put it back in the fraction like they originally did. So this would become minus 6x to the cube. Okay? See if they've got any harder ones. They look quite hard. Let's do this one. So we've got, again, just the first one, pretty straightforward. 4 lots of 9 is 36. Got my x, take one from the 4 makes 3. This is the same as 4x to the minus 3. So I need to do 4, so this is subtraction. 4 times minus 3, that's minus 12. So the first negative comes from here. Take one from the power and I get minus 4. So this is 36x cubed. Minus a minus makes a plus. So I've got 12 over x to the